Welcome to our second video on the use of units of measure in business. In the last video, we calculated 3 ratios to help us compare 6 different brands of green tea. We calculated the price per tea bag for each of them, the grams per tea bag, and the price per ounce. Just to wrap up that discussion, I want to point out that those are not the only 3 we could consider. Depending on what our goals are, we might consider others, and I'll cite just one further one, which is the ratio of weight to total price. I calculated this using ounces to dollars, ounces over dollars. I could have done grams over dollars. I just chose ounces. And we find that tea number 2 has a weight to price ratio of 1.09 ounces to $4.99, which is 0.22 ounces per dollar. Whereas for tea number 6, it's 2.5 ounces total tea divided by its price of $2.69, which is 0.93 ounces per dollar. And what that means is that $1 gets you 0.22 ounces of tea number 2, whereas that same dollar would buy 0.93 ounces of tea number 6. The choice of which ratio you calculate and use just depends on what purpose you have in mind. If you're looking for the cheapest tea per bag, you'd calculate one ratio. If you're looking for the most tea per bag, you'd calculate another, and you'd make your decision based off that. Moving on to the next major topic in this section, let's talk about converting units. In business, numbers with units are often converted into equivalent units to facilitate communication. For example, suppose a company made $1,823,764 in profit one year. In many contexts, that profit figure would be converted and rounded to ease communication. People would talk about having made $1.8 million in profit or $1.82 million in profit. They would not spell out all of those numbers. After all, once you are talking about millions, the 4 in the ones place does not matter for most purposes, and to include it amounts to verbal or written clutter. So it's not wrong to have all the numbers spelled out, but if you're writing about a number again and again and again, and you're repeating these long strings of digits, it clutters up reports visually, and it's confusing to your listeners. That's what it means to have verbal or written clutter. Unit conversions also arise when interpreting computer output from data analysis because data is often stored and analyzed in units that are not convenient when communicating results. So what computers like and what makes sense to them with their rules and their underlying technology is not always what makes sense to the humans that you're trying to communicate results to. So attention to units when you're communicating in business is important, and refreshing your skills in converting units will be helpful to you. Let's take a look at a basic example. Example 6.4 says convert 70,381 into thousands. So the number 70,381 is just counted in ones. There's an implicit decimal right here. It's not included because nothing in this number as given is non-zero after that 1. So that decimal is normally not given. But it is counted in ones, and we want to convert it into thousands. To convert a number in ones into thousands, what you're trying to do is find out how many times does 1,000 go into this number. That's what the answer in thousands is. So to convert 70,381 into thousands, we would simply take 70,381 and divide by 1,000. What that's actually going to do, because we've been through examples like this in other sections, that's going to move your decimal place, that one that I just wrote in and then erased, 3 places to the left because you're dividing by 10 times 10 times 10. But whether you want to do it by moving your decimal 3 places to the left, or whether you want to take your calculator and type in 70,381 and divide by 1,000, what you'll get is 70.381. Now, this number is not in ones anymore, so I wrote in thousands. Otherwise, somebody coming upon it might think it means 70.381 and that it's counted in ones. In this answer, I wrote out all of the decimal places after what becomes the ones place once you convert this into thousands. So once you convert into thousands, The counting numbers are thousands. So this number 0 is in the thousands place. This number 7 is in the 10,000s place when we were counting in ones. But now that we've converted into thousands, the 0 is in the ones place and the 7 is in the tens place. It's not really necessary to go into all that detail. Just understand that depending on context, this number 70.381 thousandths could be written 70,000. That would be rounded to the thousands place in the original number. It's 70,000. The reason I didn't round it up to 71 is because the digit in the next decimal place, which is a 3, is 4 or less, and so the 0 stays as is. If I were instead to round this, including one more digit, I could write it as 70.4 thousand. How did I get that? The 8 in the decimal place following the 3 is 5 or more, so I add 1 to the 3 and get 4, 70.4 thousand. Or it could be 70.38 thousand. So depending on what you're doing with the number, you might round it any of those ways. When a number is in dollars, that is usually indicated by preceding the number with the dollar sign. When multiples of dollars are used as units, they can be written out, for example, thousands of dollars, or shortened in various ways that you'll see, these 3 being common examples. A lot of the conversions you will be dealing with in business have to do with dollars. So let's take a look at an example in example 6.5. Example 6.5 says, in this snip from a spreadsheet, the column label in cell A1 shows the units for the values in column A. All right, let's take a look at the column label in cell A1, and we see that it says cost in 10,000s. It asks us to convert the two costs to dollars. So we see in cell A2, the cost 4.68, and that is in 10,000s. You see why often you don't use all of those words and simply shorten it to something like what was done in this Excel spreadsheet. And we want to convert this cost to dollars. All you have to do is reverse the process that we did in example 6.4, where to get something into thousands, we divided by 1,000. Here, we want to get something out of 10,000s, so we're going to multiply by 10,000. 4.68 in 10,000s of dollars comes to 46,800 in dollars. What about the number in cell A3? Go ahead and pause the video and do this yourself if you've got the idea. In cell A3, we have 2501. That number is in tens of thousands. So to convert it to dollars, we multiply 25.01 times $10,000, and you get $250,100. So you can hear that even in my explaining this example, it's a mouthful to talk about tens of thousands of dollars or $10,000. It is much easier to talk about $46,800 or $250,000, but the opposite is the case when you look at the spreadsheet. Much better to show 4.68 and 25.01. Data analysis in business is becoming ever more important, and the ability to communicate results clearly and effectively is a valuable skill. When you are communicating results, you will often have to convert them from the units they are in to better ones for explaining their meaning to other people. Example 6.5 is just such an example, but here is a more direct one. Example 6.6 says, a bus company recorded the cost of running its buses in thousands of dollars and its ridership in hundreds of people. While the units $1,000 or thousands of dollars and 100 riders work well to store data, those units are not the best for general communication. For that, dollars per rider would be more understandable. This snip shows the data for one bus. What is the cost in dollars per rider of running this bus? So what we have is, if we just divided these numbers, that would end up with a result that was in thousands of dollars per 100 riders. What we want is just dollars per rider. There are actually a number of ways to approach this. I'm going to start by writing out what we're working with. We have 2.13 in thousands of dollars divided by 11.4 in hundreds of riders. You can split this calculation up. If you want dollars per rider, what you can do is convert 2.13, which is in thousands, to dollars, then convert 11.4, which is in 100 riders, to riders, and then do the division. So 2.13 in thousands of dollars. To get dollars back out of that, we would multiply 2.13 times 1,000, and we get $2,130. 11.4 is in hundreds of riders. To get how many riders that is, we would multiply 11.4 times 100 riders, and we get 1,140 riders. If we want dollars per rider, we now have it's $2,130 for the cost of running this bus, divided by the 1,140 riders that they had over that period of time that this cost applies to, and rounding this to the nearest cent, $1.88 per rider. Now, if you had done the calculation from the beginning with the thousands and the 100 riders units, you would get 0.19 or 0.188. And then you would be talking about 0.188 thousands per 100 riders, and it wouldn't make any sense to anyone. But if you talked about $1.88 per rider, that makes perfect sense. Another way you can do the same thing is to combine these calculations. So starting from the 2.13 over 11.4, thousands over 100 riders, what you can do is convert by canceling units. I'm actually going to change this because I don't want it to be so confusing with everything running around. Let me just spell this out. So we're talking about thousands, and we're talking about 100 riders. So in this next fraction, what I'm doing is I'm setting up something that equals 1 when you consider the units. So if you have 1 unit of $1,000, that equals 1,000 individual dollars. So this part of the calculation I'm doing actually equals 1. And that's why we can do this, because you can just keep multiplying things by 1 as many times as you want because you get the same answer back. In this case, we're going to multiply by things that make sense as 1 in units, and we're going to get the answer in the right units back. So now we have the thousands of dollars converted to $1,000. Now let's deal with the 100 riders. I want to be able to cancel these things out. This is why I'm going to put that 100 riders, which is the top of my fraction, is equivalent to, makes a 1 when divided by 100 riders. Now let's take a look at the units that we have written out and cancel the ones that we can cancel. So when you have fractions, you can always cancel the things on the top that are the same as the things on the bottom. In this case, we extend that to the units. So we have taken care of this thousands here. We cancel out the thousands by converting them to dollars. And then we also have 100 riders on the bottom and 100 riders on the top. So those cancel, leaving the units dollars per rider. Multiplying these fractions, you get 2.13 times 1,000 times 1 on the top, divided by 11.4 times 1 times 100 on the bottom. The units on this figure are going to be the units that did not cancel out. So we are going to have dollars on the top and riders on the bottom. When you calculate out that, what you get is $1.88 per rider.